Question 9.43. A centrifuge in a medical laboratory rotates at an angular speed of 3600 revolution per minute. When switched off, it rotates 60 times before coming to rest. Find the constant angular acceleration of the centrifuge. So let us first write down what is given to us. We have the angular speed of centrifuge, which is 3600 revolution per minute. Whenever they give you angular speed in revolution per minute, this revolution per minute is basically the unit of frequency. So angular speed in revolution per minute or revolution per second is actually the value of frequency f. So I will write f equals 3600 revolution per minute. This revolution per minute I can convert to revolution per second by dividing this number with 60. So we write 3600 divided by 60. That will give you the angular speed in revolution per second, which is 60 revolution per seconds. If I have the frequency, I can calculate the angular speed in radian per second by using the relationship angular speed omega equals 2 pi f. So I can multiply my frequency with 2 pi. That will give me my angular speed in radian per second. That becomes 120 pi radian per second. Then we have when switched off, it rotates 60 times. So basically my number of revolution n is 60. Before coming to rest. Now when it comes to rest, the final value of angular speed omega f will be 0. So this becomes my initial and this is my final. We need to find the constant angular acceleration alpha. So we need to find what is alpha. I have the value of initial angular speed, final angular speed, and I need to find alpha. I can find alpha if I know the value of angular displacement delta theta. And I can calculate delta theta by using n. I know the number of revolution, which is 60. And the relationship between number of revolution and delta theta is n equals delta theta over 2 pi. So we can find the total angular displacement delta theta by multiplying my number of revolution n with 2 pi. So I substitute here to calculate my angular displacement delta theta. N is 60 times 2 pi. So delta theta becomes equals to 120 pi radian. Once I have delta theta, now I can use equation of motion to calculate the angular acceleration alpha. We have the initial angular speed, final angular speed, and the displacement. So we will use the fifth equation of motion, which says omega final squared equals omega initial square plus 2 alpha delta theta. Here delta theta is the angular displacement, which can also be written as theta final minus theta initial. I want to calculate alpha, so I will first move omega initial square to the other side to keep 2 alpha delta theta alone. So we get omega final squared minus omega initial squared equals 2 alpha delta theta. Now divide with 2 and delta theta to leave alpha alone. So we get alpha equals omega final square minus omega initial square over 2 delta theta. Now we will substitute the values to get alpha. You can substitute in the first equation here as well and do shift solve to get your answer. Or you can rearrange and write it in this format to find the final answer. So we substitute omega final is 0. Omega initial is 120 pi. We take square of this. Divide by 2 times delta theta, which is 2 times 120 pi. And when you solve this, you get the value of alpha as negative 188.496 radian per second squared. which you can write as alpha equals negative 188.5 radian per second squared.